All right, guys. We've got a little bit of time. Does anybody think they have an answer to this question? Don't tell me what you think it is yet. Just hold your hand up if you think you've got an answer to this question. A couple hands up. A few of them going, I think maybe, but I'm kind of not sure. And a lot of you are going, okay, how many today? I don't think I've got an answer to this question at all, or I don't know where to start this question. Okay, there's a couple more things. And a few of you are desperately watching the clock for lunchtime, right? There's a few of those going on too. All right. Here's what we're trying to accomplish with this little thing and with this process. I am forced to work with whatever is inside this sine function. So in other words, 5x in this case. In order for me to apply this theorem that I'm working on, the denominator also needs to have a 5x on it. So then I've got the entire quantity being this value and this value matching. I don't have that at the moment, do I? But I do know in the denominator that that 3 can be factored out of the denominator. Is that correct? Okay. I also know, and if you want me to write it in this step or write it in another step, that if I multiply the whole fraction by 1, I have an equivalent fraction. Now, what version of 1 should I probably consider when I think about multiplying this fraction by 1? I heard it. Want to say it louder, please? That's what it is. So I factor the 1/3 out of the denominator, but then I'm also saying, you know, if I can multiply the whole fraction by 1 in the version of 5 over 5, I'm going to specifically take this 5 times that x, and that will then give me in that denominator the 5x I need. Is that correct? Okay, those are all proper algebra skills, right? So really what we're going to do is I'm actually going to tag this 5 right here, and I'm going to bring it over here to be with that fraction of 1/3, and that fraction is actually going to look like 5/3. And then it's going to still be the sine of 5x. And then this 5 right here gets multiplied to that x right there. That's not a distributive property, it's just reassociating with the associative property. I'm going to group them this way instead of that way in the denominator. And now I've got this fraction here of sine of 5x over 5x, and we now know as the limit as x approaches 0 of this fraction, what do we get? That fraction becomes a 1 because the angle listed here and the value of the denominator are identical. So now I have 5/3 times 1. What is 5/3 times 1?
5/3.
It is just 5/3. Which is the answer to that question.
Did you get that? Yes.
Good stuff, isn't it?
Oh, yeah.
All right. One more real quick thing before we move on. There's another one of these specialized functions or specialized limits that could come out of the squeeze theorem, and it happens to be this one. The limit as x approaches 0 of 1 minus the cosine of x divided by x.
Oh, wait. Doesn't that mean sine?
It would be 1 minus cosine squared to be sine. It's not the sine. That one's obviously 0 by the squeeze theorem.
Oh, obviously?
No, not really. You got, I think there was either one in your homework from that first day or one of the ones I didn't do in your homework that was this one. If you set up a table of this thing, you're going to find out that it does actually become 0. It settles in at 0 on either side. The squeeze theorem helps us do that. But you should find an example of that within your homework. What's going on?
So we don't have to solve this?
No. You just need to know that answer's there. Uh-oh.
Why?
Well, later,
In
the next, it's preparing for actually the next chapter. We're going to prove some things in the next chapter that I'm going to need these special ones for.
Okay.
But you won't have to do the proof yourself. I will do the proof because it's fun.